Hello, everyone, and welcome back to my online teaching platform. We have a question here, and we are to differentiate y is equal to x minus 3 from the first principles. So it means we are to determine the derivative of the given function, but we are to use a given or a particular approach or a particular method, which is the first principles. All right. Now, what type of function is this? You could say that this is a linear function, so you can use the comparison method. That's where you are supposed to compare the given linear function with the general form of any linear function, so that the coefficient of the x in the general form, which is the m, is equal to the coefficient of what is given, or that's the coefficient of x in what is given. Let us start work and look at how best we can find this. Let's put the function down first. The function is y is equal to x minus 3. So when you compare this with the y is equal to mx plus c, you could see that your m is equal to 1, because the coefficient of x here is 1. So you can put 1 here. So the derivative of the given function is equal to 1. But we have been told to use, or we have been informed to use the first principle. So we can't use this approach to determine the derivative. So we have to use the first principle approach. So let us put the formula down. dy dx is equal to the limit of f of x plus h minus the original function, all divided by the small increment as the small increment approaches 0. So this is the formula that we'll be using. Let us get our function. So our function is y is equal to x minus 3. So which implies that our f of x will be equal to x minus 3. All right. So if our f of x is equal to x minus 3, let us find our f of h. So our f of h will be equal to x minus 3. But are you sure that the value is x minus 3? Which is wrong. X minus 3 is rather the original function. So it implies that we are going to substitute x plus h for x in the original function. So in the original function, we have x minus 3. So it means wherever you see x, we put x plus h value. So we have in place of x plus h, then minus the 3. Right. So this become our f of x plus h. So we can now substitute. So we are going to get dy dx, which is now equal to our f of x, which is x plus h minus 3. Then minus the original one, which is, so because the term are two, it's not just one term, you have to put them in bracket. So x minus the original one, which is x minus 3. Okay, so we have the f of h minus the f of x. So all divided by half. Let me clean it. So all divided by the h, but I omitted the limit. So let me bring it back. I omitted the limit, so let me bring it back. So it should rather be dy dx is equal to the limit of the expression f of x minus f of x plus h minus f of x divided by the small increment as the small increment approaches 0. All right. So we continue to evaluate. So we are getting the y dx is equal to the limit of, so we can now simplify the numerator. So we are going to get x plus h minus 3. Now negative times x will give us negative x. Negative here times negative 3 will give us positive 3, all divided by h as h approaches 0. So we continue to simplify. So we will be getting, alright, here is x. This x cancels this. And yet we have 3 here. So this one also cancels this. Negative 3 plus 3 will give us 0. So we are left with a limit of h divided by h as h approaches 0. Alright. So we'll be getting the limit of 1, because h divided by h is equal to 1 as h approaches 0. Alright. So this is a constant function. So anytime you are finding the limit of a constant function, the answer is still the same as the function. So it's going to be 1. So we are getting 1. So which implies that the derivative of what we have been given, that is the function given, is equal to 1, which is the same as the first method that we use when we compared the given function, with the general form of a linear function. So this is how we go about it. But you can use the comparison approach. When you are comparing, it means you are dealing with a linear function. But when it comes to quadratic, you cannot compare. That one, you have to use the first principles approach when you have to use it. So you cannot compare unless you use a different method, maybe the power rule, and you will be able to get the derivative. Thank you for watching. And do not forget to subscribe to my YouTube channel, which is Maths with Ebefa. Thank you so much.